This video is sponsored by PCBWay. Flea weights are one of the smallest weight classes in combat robots. They are a 75 gram robot, and I have taken a couple of shots at building them in the past. None of them have worked out very well, so today we're going to try again, and this time, hopefully, get it right. Now, every time I've done this in the past, I have set myself the challenge of having a weapon on my flea weight, because I feel like if I'm going to put the effort into this challenge, I want to actually add the extra thing of having some form of articulation or weapon on the robot. This time around, I want to do the most destructive weapon I can, and we're going to do that by stealing. Specifically, we are stealing this weapon motor and weapon combo from Nucleus, my 150 gram version of the Hacksmith's Orbitron, because this is a nice little package. It has a steel weapon and a brushless motor all in one. So of course we are going to need a way to securely attach it to the robot, and that is where PCBWay comes in. They have sent me a bunch of tiny little PCBs, which are basically a mounting system for this particular brushless motor. The bolt holes line up exactly with all of these, and then I've left holes in the base as well so that we can glue and screw this into an eventual chassis so that these will never ever go anywhere. This works really, really well. It was done in Nucleus as well, but PCBs are lightweight and really, really rigid, which provides a perfect mounting solution for a weapon like this, because if you mount a weapon like this on something a little bit flexible, half the energy of the hit is going to be absorbed by its own mount, which does not help engage and give the energy into the opponent. So a nice little PCB is going to do quite a good job here. The only problem is this is 20 grams, which is a lot of our 75 gram weight limit. But I think I can make this work. And the way to do that is to make cuts in other areas. And this is where we're going to do it, the drive system. So this is an N10, and this is an N10 with a plastic gear motor. But at 8 grams and 6 grams, these things are far too heavy for us to actually use now with our 20 gram weapon. So instead, we're going to use this. This is a tiny, tiny little coreless brushed motor with a tiny plastic planetary on it. And I've attached an output gear already because the shaft on this is only 2 millimeters in diameter, which is nowhere near enough to support the weight of a robot. So we are going to run the wheel on a separate drive shaft, just to make sure that this motor is not taking all of the brunt. But the reason we're doing this is this entire setup, including this external gear here, is 2 grams, which is going to help us save a ton of weight as compared to our drive systems underneath, because this is 2 grams for 1, 4 grams for 2, which is lighter than a single one of either of these motors. This compromise doesn't come without issues though. Coreless motors like this one are very small and don't have a lot of thermal mass to them. You can only run them on 3 volts, otherwise they are going to burn up. And in this case, because there is a plastic gearbox up the front, it will just melt the entire plastic gearbox, which is problematic because our big weapon we want to run on 2S, 8 volts. So running these drive motors means adding extra electronics. So here is what our wiring is going to look like. We have a tiny brush ESC and a 3 volt voltage regulator, which thankfully these coreless motors don't draw a lot of power, so we can just run a tiny little voltage reg to run those. And together all of this stuff is actually going to be easier to wire up and just a little bit lighter than putting a Malinky or something similar in there. We've also got a 2S, homemade 2S LiPo battery, a receiver, our brushless motor, and then we have the ESC for the brushless motor. Now, in Nucleus, I put in tiny little ESCs that were only rated for 5 amp, and they stalled the motors when they hit something. So this time, I'm going to spare the extra weight and put in a 20 amp ESC to hopefully spin through every single hit that we produce. But yes, that there is basically all of the wiring. So realistically, all we need to do now is solder it all together, and that looks like this. So this is all now wired up, but it is actually the second version of the wiring. The first version, I had a couple of plugs in here and unfortunately the whole robot was overweight. So I did a little surgery and took some plugs out of the system so that the thing is just a little bit easier to put together, and also 4 grams lighter, which is a good saving in this particular robot. Now let's actually have a look at the chassis. Here it is. This is our chassis, and as before, we're going to use a PCB to hold the weapon motor in place, and it just slots in there like so. And there's holes in the side to put bolts down in through, including holes in the chassis to get a screwdriver in there. I don't think we're actually going to need it. I think we should just be able to glue this in place. And realistically, that is the next step. So that's what we're going to do. So I've done this a couple of different ways in the past using different levels of slow and fast cure epoxy. I've also used super glue, and that's the quickest and easiest way and seems to work basically just as well as any other method. So that's what we're going to do today. Next, we're doing the wheels, which are just a rubber band that need to be glued onto this ABS tire. So I've got the good red and black super glue from Bunnings to do this because it's probably the only thing that will do this. And I'm just going to go around and add a little bit of super glue here and there, trying not to overdo it, because what I don't want is super glue to overflow the rubber and harden it up and make it useless as a tire. I mean, this is a weaponed robot, so it doesn't need the most traction in the world, but some would still be nice. That should be one wheel, and I've done a whole second one of them. Finishing this off is fairly easy. All we're going to do is thread these into pre-threaded holes in the chassis, and once they're in, I need to tighten them down most of the way, but not all the way. I'm then going to add a drop. See, that's too tight because it doesn't let the wheel spin freely. If I back it out just a little bit, that's perfect. And then I'm going to add a drop of hot glue in there to hold that in place, and then cut the end off so it really can't come out. So it's time to start looking at putting our motors in, and for this I'm going to do something I've never done before, but I figured it was worth a try here, and that is I'm going to double-sided tape my motors in place. I do have little clamps to hold them as well, but most of the force on these is going to come from this double-sided tape to hold them into that spot right there. And I have no idea how this is going to go. Probably poorly, to be fairly honest, but I wanted to try it as, look, this is a tiny little robot and it's running tiny little motors. Sometimes you can get away with things you can't get away with otherwise. With that in, it is time to work on power, which is this little 2S battery, which should slot in the back here, just about behind these motors. Yeah, look at that, perfect. Goes in right here, and I can tuck this guy to one side, just like so, and then the power wire goes over this way. And then our switch is going to be attached to the wall. Here's our switch. This is going to be attached to this wall with more double-sided tape because, again, it's easy, but this time we're going to use some thicker foam stuff. From here, it really should just be a matter of packing the rest of the electronics in here, which can actually be a little bit tricky, but that's okay. We should first plug in the ESC for the weapon and then just kind of jam everything in. This is probably going to take a second. All right, it's starting to look pretty good. We'd even be able to get the lid on at this point. It is a little bit bowy in the middle, but that is totally fine. So the next thing to do would be to put the weapon on, which should be fairly easy. We've done this thing before a number of times. We're just gonna pass wires in through here and then curl them round inside and plug them into the ESC. And of course, once the wires are through, we can actually bolt the thing into place with just a couple of M2 bolts through the back here. No, 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 no. During that pack, I broke the battery wire at a point really, really close to the battery. So close, I don't know that this is going to be salvageable anymore. Done a very, very quick patch job on this battery. It should work. I've also hot glued all the wires down a little bit better. Hopefully that didn't affect the battery in any way, because it was a decent amount of heat right on the battery. But there's only one way to find out, and that is to put this thing in here. Now, the other thing that's happened is that we were a little bit close on weight using the printed lid, so I have gone to a Team Panic classic of a bit of milk jug as a lid. This should do us totally fine for what we need in competition. I don't think there's going to be any overhead saws in the flea weight competition, or at least I really, really hope not. And there we go. It is all done. And we're going to do the final weight check together here. I have no idea if we're going to make, well, I'm pretty sure we're making weight here, but let's see what we are at. 73.4. Woo! Okay, yeah, so the new lid, not using this one, definitely helped. I probably could actually print an ABS one that's just one layer thinner than this one, and it would actually probably do a slightly better job than this milk carton top that we've got at the moment. But the next thing to do is to actually test all of this. And obviously I can't do any kind of out of the box testing because this weapon is glued onto this motor. They are one and the same. If I do any testing, it has to be in the test box. So let's do that. And there it is, a 75-gram flea weight. Overnight, I did reprint the lid to be just a little bit thinner, so this is actually now sitting at just under 75 grams with that lid included, which I'm really happy about. I like the look of the thing when it is all yellow, so I don't think I'll go back to the milk carton top that I had before. The test was really, really good. The only thing I'll say is that the drive is a little bit squirrely. I think because most of the weight is in front of the drive wheels, it does not spin on the spot very well. But other than that, like, it drives pretty well in a straight line, and realistically, that's all I need. I just need to be able to charge at somebody, right? Right? Look, we'll find out when I go and fight this thing very, very soon here. But I think regardless of that, on the whole, this is probably my most successful flea weight. This is probably the flea weight I am the most happy with. I didn't think that some of the things in here would work, and they absolutely have. This weapon I thought was probably even going to be maybe a little bit too heavy for fleas, and yet here we are. We have a flea with that all incorporated. So I am very, very happy about that. Anyway, that is going to be it for this video. I hope you have enjoyed that one, and I will see you in the next video.